As with any calculation, when you're expected to describe the practical details or design an experiment, what you must do is storyboard it. So I've used Chemix here to get the apparatus that I'm going to need. And then when we design an experiment, we need to look at the scale or the amounts of substance we're going to use. So then we take into consideration the apparatus before we can go on to the method that we're going to use. And then the calculation is the analysis and any errors carried out in the evaluation. So if we visualise using a storyboard the apparatus that we're going to use, we've been told here we've got 50 centimetres cubed of the acid, and we know that its concentration is 2 moles per dm cubed. So I'm just going to put that into there. So the original concentration of the acid was 2 moles per dm cubed. And what we're going to do is we're going to put some pure calcium hydroxide into the hydrochloric acid. But then it tells us here the unreacted acid, which means that the acid must be in excess. So that means not all of the acid has reacted. So the unreacted acid is then transferred out of the conical flask using a pipette and into a conical flask. It's then titrated with some standard sodium hydroxide solution so we can find out the amount of acid that remains over after it's reacted with the calcium hydroxide. So if the acid is going to be in excess, we need to work out the mass of calcium hydroxide that we're going to dissolve in the acid to react with it. So the amount of hydrochloric acid present is simply its concentration times its volume, and because the volume is in centimetres cubed, we divided it by 1,000 to convert it to decimeters cubed. So the amount of HCl is 50 times 0.02 divided by 1,000 moles. Now if we look at the equation, we can see that there are 2 moles of HCl to every 1 mole of calcium hydroxide. And remember that the moles of calcium hydroxide has to be less than the moles of HCl. So if we wanted the exact moles of calcium hydroxide that would react with that hydrochloric acid, we need to divide this number of moles by 2. So the maximum number of moles, or the maximum amount of the calcium hydroxide is going to be 50 times 0.2 over 1,000, but we then need to divide that by 2. We can now calculate the maximum mass of calcium hydroxide that we can weigh out. So the maximum mass is the number of moles times the MR, which is equal to 5 times 10 to the minus 3 moles times 74.1 grams. So remember, the acid has to be in excess. So tell the examiner you're going to weigh out less than 0.371 grams of the calcium hydroxide on a top pan balance. So this calcium hydroxide is going to be dissolved in 50 centimetres cubed of acid. And then that mixture with the excess acid that's reacted with all of the calcium hydroxide is then going to be titrated against sodium hydroxide. So what scale of sodium hydroxide are we going to use? Well, since we use 0.2 moles per dm cubed acid, we could use 0.2 moles per dm cubed of the sodium hydroxide. So since the sodium hydroxide is going to come out of the burette, the volume that we're going to use, if we just call that V, the amount of sodium hydroxide that's going to come out of the burette is therefore going to be 0.2 times V. And since the sodium hydroxide and the hydrochloric acid react in the same ratio, the moles of HCl that was left over from the reaction is also going to be 0.2 times the titration volume over 1,000. So now we know the amount that's reacted with the calcium hydroxide, because we know the total moles of HCl that we added at the start, that was in the 50 centimetres cubed. We know the number of moles that's reacted with the sodium hydroxide here, and therefore if we take the amount that's reacted with the sodium hydroxide away from the total amount of the HCl, that will leave us with the HCl that's reacted with the calcium hydroxide. So there's the total amount of HCl that we had at the start. This is the amount that's reacted with the sodium hydroxide. So if we take that smaller number from the total, that will give us the moles that reacted with the calcium hydroxide. And because the ratio is 2 moles of HCl to every 1 mole of calcium hydroxide, it therefore follows that the moles of calcium hydroxide is 1 times 10 to the minus 2, take away 0.2 times the volume from the sodium hydroxide times 10 to the minus 3 all over 2. Now we have the moles of the calcium hydroxide, we can then work out its MR, because we know that the MR is equal to the mass that we weighed out divided by the number of moles. So we know the mass, which was here, which is less than 0.371. We've now worked out the number of moles, and that will give us the accurate MR of the calcium hydroxide. This part of the question was really straightforward. First of all, it's important you write out the balanced equation to get the molar ratio. So calcium chloride is dissolved in water, so it's aqueous. It's then reacted with sulfuric acid, and as we know, calcium sulfate is insoluble, so we get precipitate of calcium sulfate and hydrochloric acid. And the ratio for the calcium hydroxide is 1 forming 1 mole of calcium sulfate. So the first thing we can do is we look at our mass, and that will give us our amount of calcium chloride in moles. That's the mass divided by the MR. So that's the mass of calcium chloride divided its MR, which is 111.1, which is 3.204 times 10 to the minus 2 moles. And therefore the amount of calcium sulfate is also 3.204 times 10 to the minus 2 moles, because it's a 1-to-1 ratio. Write the equation for the percentage yield. It's really important that you do this. So percentage yield is actual over theoretical. So remember, that could be actual mass or actual moles. Since we've got moles here, we're going to use moles. Now we do know the percentage yield. We know the theoretical number of moles, so we can actually find the actual number of moles by rearranging this. So this equation is your actual moles is percentage yield times the theoretical divided by 100. So make sure you can rearrange that equation. In rearranging that equation, there's the percentage yield, 83.4, times the theoretical number of moles, which is 3.204 times 10 to the minus 2, divided by 100. Little typo there. Divided by 100. Now we have our actual moles. We can then find the actual mass times the number of moles by the MR of the calcium sulfate, which is 136.2. Now it does say to the appropriate number of significant figures, and since the smallest number of significant figures is 3, your answer must be given to 3 significant figures. So that's 3.64 grams.